There are some very easy rational equations, and you might have even solved equations like this in Algebra 1. If each side of an equation has just one rational expression, like you can see one rational expression, there's no plus or minus or anything like that, what technique straight from 5th grade can you use to solve it? Cross multiply. The old butterfly. Cross multiply. Now this does not work for all of them, but it does work for ones where if you just have one fraction equals one fraction. Remember, there are some values that are not in the domain of a rational function because x can't be all numbers. There's often a few that are excluded. So it is going to be very important for us to check for extraneous answers. Check for extraneous. Okay. So when I look at the first one, like before I do anything, I'm going to go ahead and figure out what my two denominators cannot equal. Okay, what are my two denominators not allowed to equal? On this one, what would make this denominator 0? Yep, so x can't be 2. And then for the second one, 5, because that would make 10 minus 10 would put my denominator 0. So if we get either of these two answers, we'll have to mark them out. They'll be extraneous. But we do have just one fraction equals one fraction, so I know that I can cross multiply these two. Man, it feels nice to cross multiply, right? So that means we're going to need to do 7 times this entire denominator, 7 times 2x minus 10. And we need to set that equal to 11 times the x minus 2 denominator. 11 times x minus 2. And then looking at that, we can just do a little distributing on both sides, giving us, what is that, 14x minus 70 equals 11x minus 22. We do have variables on both sides, and we don't want that, so we do need to cancel one or the other. It doesn't matter which one y'all want to cancel. The 14 or the 11? Yeah, I want to cancel the 11. Danny is a creature of habits, just like me. Alright, so that would make 3x minus 70 equals negative 22. And then we'll add 70 to both sides, giving us, what's negative 22 plus 70? Or 70? 48? It's okay. And then one last step to get the answer. Divide. Divide by 3 and we get x equals 16. Yeah. Or the top two, because you just have one fraction equals one fraction. Is that one of the numbers that x was not allowed to be? No. So this is a good, perfect answer. Yeah, the top two are, I like the top two. They're nice. Got our doodlers doodling.
They're calm.
Alright, second one, again, we do have it to where we just have one fraction equals one fraction, so we can use cross multiplying on this. But again, I'm going to go through and just list out what x's are not allowed to be. What would make this denominator 0? No, 0. X is not allowed to be 0, and x is not allowed to be, what would make this one a 0? 7, right. So if I get either of those two numbers, I'll have to mark them off. They'll be extraneous. Again, we just have one fraction equals one fraction, so we can cross multiply those two. So we'll get 3 times x minus 7 equals 2 times 5x. You only have to distribute on the left. The right, you just have to multiply. So 3x minus 21 equals 10x. Variables on both sides, which one y'all want to cancel?
Yeah.
You can't have it both ways, Danny. 3x minus 10x is negative 7x minus 21 equals, I have to write something, 0. Then what? Add 21 to both sides, so negative 7x equals 21. Divide both sides by negative 7, so x equals negative 3. Is that one of my two numbers that it's not allowed to equal? Nope. So, oh, yes. Does it have to be what? Oh, no, it doesn't. Sometimes I mix it up and I do it the other way. Just an equal sign with a slash through it. Yeah, it might be based on which hand you're using. Okay. The next two are not written as proportions. What if it's not written as a proportion? So I'm going to write out an Algebra 1 equation. If we're having some side conversations, we can pause the side conversations. I'm going to write out, hold on. I'm going to write out an Algebra 1 equation to kind of get you to think about like why we solve them in this certain way. So say we had an Algebra 1 equation that said 1/2 x minus 3 equals 1/4 x plus 2. What would we need to multiply everything by to get rid of these fractions? 4. Guess what 4 is? The least common denominator. Right. So our job when we have like a fraction, and it's not necessarily just one fraction equals one fraction. You'll have some other term. You will need to multiply each side by the least common denominator, or aka multiply everything by the least common denominator. Multiply everything by the LCD. And remember, we learned how to find LCDs yesterday, but obviously we can review that. So starting with the first pretty easy to find an LCD. Yeah, your LCD, there's only one factor that shows up in any denominator. Again, if it shows up in two denominators, you got to write it twice or no? No, that would just make it a common denominator and not a least common denominator. So I need to take this whole equation and multiply everything by x minus 3.
I got a question for the least common denominator. No, I'm so lost when I'm playing this.
Okay. Alright, so we'll start out with x minus 3 times the 6 over x minus 3. And then we have minus 4 that we're going to multiply by that LCD also. Equals, and then we have 2 over x minus 3 that we're also going to multiply by the LCD. Okay. So it looks terrible right now, but it simplifies beautifully. For the first one, what can I cross out? Yeah, your x minus 3's will literally cancel. And what are you just going to be left with? A 6. For the second one, we have a negative 4 that we need to distribute. So that would become what?
Negative 4x and 12.
Negative 4x plus 12. Very good. On the right side,
It's going to be 2.
yeah, because our x minus 3's cancel. Look how beautiful that was. Didn't that turn out nice?
We add 12 and 6 to minus 6.
Yes, you can add your 12 and 6 to get negative 4x plus 18 equals 2. Which means x equals 4. What is the only number our denominator is not allowed to be? Yeah, so x is not allowed to be 3. Is this that number? No. So is this a good answer? Yes, this is a good answer. Yes, hon? Can you not? You can, if you want to. Yeah, because once you bring 2 to the other side, then you would just have to bring something else back over where the 2 was, so it doesn't matter.
But can you tell me what the least common denominator is?
Don't worry, we're doing least common denominator on all of these today. You will get more practice with it. Alright, looking at the next one, let's look at all those denominators. Because we got to figure out what our least common denominator is. Okay, the least common denominator has to include every denominator that shows up, but if it shows up in more than one denominator, you don't have to write it twice. So I need to have a 2 in my LCD. And what else do I need to have? A 4 minus x, right, because those are all the numbers that show up in a denominator. So if I multiply this whole entire fraction by this least common denominator, it should cancel out all the fractions. Yes, Paul?
Would we theoretically be able to multiply 2x by 2 and add x plus 3? And
Yeah, you could basically turn them into like a fraction equals a fraction. That's alternate method, yeah. He's basically turning it into a problem that looks like this. He wants to just kind of combine the two on the left, get a common denominator, and then cross multiply. Mm-hmm. Alright, let's multiply everything by the LCD. Okay, so again, we're multiplying by the 2 times 4 minus x to every term, every part of it. Okay. So I'm going to start with taking my LCD, 2 times 4 minus x, and multiplying it by the x plus 3 over 2, plus, and then we'll have the 2x times the LCD, which is 2 times 4 minus x, 4 minus x. Okay, and then on the other side, I'll have 6x plus 1 over 4 minus x times the LCD, 2 times 4 minus x. Okay, looking at the first one, what's going to cancel? The 2, very good. And then what do we need to do with the 4 minus x and the x plus 3? Multiply them out, yeah. That would be, let's see, 4 times x would be 4x. And then we'll have 12, and then negative x squared, and then negative 3x, leaving us with negative x squared plus x plus 12 when we combine this one and this one. Negative x squared plus x plus 12. Okay, for the second one, does anything simplify? No, nothing simplifies. So we just have a 2x times a 2 times a 4 minus x. So a 2x times a 2 times a 4 minus x would become 4x times 4 minus x. And then if you distribute that, you would get 16x minus 4x squared. So we'll have plus 16x minus 4x squared equals, and then what about on the right side? The 4 minus x does what? Cancels, very good. And then we'll just have the 2 times the 6x plus 1. I think I can do that one in my head. 12x plus 2. What type of equation do we have? It's quadratic, right. Alright, let's see. We got a negative x squared minus 4x squared. That would make negative 5x squared. We got an x plus a 16x, which would make 17x plus 12 equals 12x plus 2. What does the equation need to look like in order to solve a quadratic? Yes, and we need to set it equal to 0. Set equal to 0. Bless you. I like my x squareds to be positive, so I think I'm going to cancel everything from the left side. So I'm going to add 5x squared, subtract 17x, subtract 12, plus 5x squared. Okay, so cancel, cancel, cancel. I'll get a 0 equals a 5x squared. A 12x minus 17x would become negative 5x. Good job, Sean. And then a 2 minus 12 would become negative 10. Good job. I can make this a little easier by doing what? You don't even have to factor out a 5. You could just divide everything by 5, yeah. Because you have a 0 on one side, you could just divide by 5. So 0 equals x squared minus x minus 2. Easy factoring. Two numbers that multiply to negative 2 but add to negative 1. 2 and 1. Yep, the 2 has to be negative, the 1 has to be positive. So if we take each one, set it equal to 0, and solve it, we'll get x equals -1 and x equals 2. Now let's think about what numbers the denominator is not allowed to equal. What are we not allowed to equal? 4. Yeah, 4 is the only number that would make a denominator equal to 0. X can't equal 4. And this is not one of those numbers. So how many solutions do we got? 2 solutions on this one.
Wait, but what happens to the bar? Isn't it still?
No, we divided by it. It's gone. No, this is important. Thanks. No, if it was just 5x squared and you didn't have an equals 0, then you could just bring it down, I guess. But since we weren't just factoring, we were solving, we were allowed to just divide by it and let it go away. Bailey, I do need you to lift your head, though. This is not sleepy time. Thank you. All right, let's look at the back. Again, we're solving. We're checking for extraneous. I'm going to start by listing out the numbers that my denominator can't be. There's 2 of them on this one. -1. -1 would make this denominator a 0. And what else? A 0. 0 would make both of these, right? All right. Paul, what's your shortcut on this one?
If we add 5 over 2x to both sides, we can just get a very simple equation.
Yes. If you look, both of these have the same denominator. So Paul's saying if you take this whole thing and cancel it by adding 5 over 2x, it turns into a simpler equation like the first 2 that we had on the front. Mason, please put my marker down and stop wasting it. So it would give me 3 over x plus 1 equals 8 over 2x, because we only have to add the numerator, so the denominator stay the same. And then it's just like the first 2 that we did on the front. You just have one fraction equals one fraction. If you just have one fraction equals one fraction, how can you solve it? Cross multiply, yeah. So one diagonal would give me 3 times 2x. The other one would give me 8 times x plus 1. Distributing on the right. And then what? Then what? Subtract. Keep your variables on one side. And we got, let's see, that would be -2x equals 8, which means x equals -4. Is that an okay answer? Yep, because that would not make either of my denominators 0. So yeah, sometimes, as Paul noted, there's sometimes you can just kind of look and see, well, maybe if I just added them together. You just add them together. All right, last one. This one, it doesn't look like either of them, any of them have same denominators yet, so it's not going to be just a quick like, oh, let me just add it to the other side. So I am going to multiply by my LCD on this one, which means I need to figure out what the LCD is. Right, x squared minus 9 is x minus 3x plus 3. So your LCD needs to have every factor that appears in a denominator. If it appears in more than one denominator, you don't have to write it twice. X plus 3, x minus 3. So we should be able to multiply everything, every term left, and then both terms on the right by that least common denominator. It's going to cancel out a whole lot of it, yeah. Okay, so to all 3 terms. So let's see, we'll start with having the LCD, x plus 3, x minus 3, times the first fraction, 6 over x minus 3. And we have an equal sign, and we'll have that same LCD times the 8x squared over the x minus 3x plus 3. And then we have minus 4x, dang, I'm running out of room on this one, over x plus 3 times the LCD. times x minus 4, x minus 3x plus 3. X minus 3x plus 3. Okay. I wasted too much room on that first term. For the left side of the equation, what all is going to cancel? X minus 3, right. And we're just going to be left with 6 times x plus 3, which would turn into 6x plus 18. Good job. And then we have an equal sign for this middle term. What cancels? Yeah, the entire denominator, and leaves us with just 8x squared. Okay. And then on the last one, the x plus 3 will cancel, and we'll just have the minus 4x times x minus 3 minus 4x times x minus 3 would be what?
Negative 24 subtract plus 12.
Negative 4x squared plus 12x. Negative 4x squared plus 12x. Negative 4x squared plus 12x. All right, again, what type of equation did it turn into? A quadratic, right. So we will need to set it equal to 0. We also have some like terms we can combine. 4x squared. I'm going to subtract my 6x and subtract this 18. Leaving me with, let's see, that would be a 6x minus an 18 equals 0. Mason, what can we divide by? 2. Yeah, we can divide by 2. We have a 0 on one side, so you don't even have to bring that 2 down anymore. It's just gone. 2x squared plus 3x minus 9 now. Two numbers that multiply to negative 18, but they need to add to 3. 6 and 3, 6 and 3. Yes, 3 would have to be the negative one. So we'll have 2x squared plus 6x, you're welcome, Danny, minus 3, minus 9. Grouping GCF of the first group? 2x. X plus 3. GCF of the back group? Negative 3, leaving us with x plus 3. So one factor is going to be 2x minus 3. The other factor is going to be x plus 3. Okay, then I'm going to take those and solve them. One's going to be 2x minus 3 equals 0. The other is going to be x plus 3 equals 0. Not negative 3 over 2. Regular 3 over 2 and negative 3. Let's go back to think about what our denominator is not allowed to equal. Denominator is not allowed to equal negative 3 and 3. Did we get one of those? Yes, we did. So what do we do with this negative 3? Cross it out. It's extraneous. If it was a multiple choice question, you wouldn't even circle an answer that had that. You would only have 3 over 2. Alright. This one looks fun. If 5 over x equals 15 over x plus 20, what is the value of x over 5?
Oh, you can cross multiply.
You could cross multiply, right. What's our game plan on this? Cross multiply to do what? What is the purpose of that? To find the value of x, and then once we have the value of x, we can divide it by 5. Game plan. So yes, we can cross multiply because you just have one fraction equals one fraction. So I'll have 5x plus 100 equals 15x. Yes, 100 equals 10x, which means x equals 10. So to answer their question, what is the value of x over 5? It's 10 over 5, which is 2. Yes?